Okay, so we looked at the block method and we looked at the Japanese line method. There's another couple of different ways, ancient ways of calculating that are pretty cool, and I'd like to show you those. This one reminds us of the block method, but it's slightly different. We put our one number at the top here, 333, and then we put our other number to the right on the side, and then we divide all of these blocks up. With a diagonal in the middle. And if you do it on lined paper, it looks a lot neater than mine, but you get the gist of it. Okay, and then we actually think, what is the product or the multiplication of 3 times 2? Well, we know the answer is 6. So 10's here, there are no 10's in 6, and 1's here. So 3 times 10, 3 times 2 is 6. 3 times 4 is 12. 10's here, 1's here. 3 times 2 is 6, no 10's, 6 1's. 3 times 4 is 12. 10's first, units underneath. And then 3 times 2 is again 6, and 3 times 4 is 12. Okay, what does this help us? Well, what we actually do now is we take a coloured pen and we add everything that's in this row together. And we always start in the bottom right hand corner. So this one's easy, there's only 2 1's. So the number of 1's we're going to have in our final answer is going to be 2. And then we take our next row, which is this one here, and add everything in that row. 2 plus 1 is 3, plus 6 is 9. If we'd had 19 or anything like that, we'd actually carry that over to here, and that would have given us a 1 in the hundreds column, but we didn't actually have a carryover. Then we add up all the numbers in the next row, which is here. So we have 6 plus 1 plus 2 giving us 9 again. So in the hundreds column we had 6 plus 1 plus 2 giving us 9. And in the thousands column, 6 plus 1 giving us 7. And in the 10,000 column, we actually had nothing. So now here we have our answer, and we start writing the answer from the top left-hand corner. So 333 times 24 is equal to 7,992. If we'd had decimals in this question, how would we have done it then? Could we have used either any 3 of these methods? Yes, we could. We could have actually thought of using if I was going to multiply 3.33 by 2.4, how would I do that? Well, actually, I'd do the multiplication as if it was whole numbers, and I would use the answer that I got from the whole number answer. I know that it would be the same numbers in exactly the same order. So 7992. The only difference is, if I look at the factors here in my multiplication, factor times factor equals product. So in my first factor, I had 2 digits after the decimal point. In my second factor, I had 1 digit after the decimal point, and that means that I've got to have the same number of digits after the decimal point that I had in all of the factors. I had 3 digits after decimal point in my factors, so I need 3 digits after the decimal point in my answer. So 3.33 times 2.4 is going to give me the answer 7.992. And it's nice to do it without the little help that method there. Let's just take a quick check on that. So we had 333 times 24 giving us 7,992. We have 3.33 times 2.4 giving us 7.992. So same numbers in exactly the same order. The only difference is that the number of digits after the decimal point should be the same as the number of digits we had in the decimal point and our factors. And then I'll show you the old traditional method of multiplication, which many of you have learned, I think, in school. 333 times 24. The first thing we do is we remember that multiplication we do from the right hand side. We always start with our units, so we're multiplying our ones by 333. So we start with 4 times 3 is 12, 2 is ones, and then 3 times 4 is 12, so we have one 10 unit that moves over to the next. We remember this as our little memory number. So 3 times 4 is 12. We write 12, 1 on the left, 2 on the right, and that's how we write it in our answer as well. Then we do our next number, which is 4 times 3 is also 12, but now we have our addition number here, so remember that this is what we add afterwards. 3 times 4 is 12, but we had 1 to add here, that's 13. So take that one away and we write 13. We write 13, 1 to the left and 3 to the right. 1, 3, 13. Now we've multiplied 4 by 30, and now we multiply finally 4 by 300. So 3 times 4 is 12, plus 1 is 13. We don't have any to carry over the next time, so we write the whole answer as 13. So now we've multiplied 4 by 333. Now we have to multiply 20, and remember this is not a 2, this is 20. In order to remember that this is 20, we have to put in a 0 on this row. So we move one step to the left before we do the multiplication, because 20 is to the left of 4. Then we do our multiplication as normal. 2 times 3 is 6, 2 times 3 is 6, and 2 times 3 is 6. And we write the new numbers under the old ones. The reason that this is super important to remember one step to the left, I usually put a little dot around that 0 when we're multiplying tens so that we don't forget to add it into our multiplication. So we're really multiplying 20 by 333, which will give us 6,660. Now we've finished with the multiplication of the 2's as well. We've multiplied both the 4 by 333 and the 20's by 333. So now we can just add up and we'll get the final answer. 2 plus 0, 2. 6 plus 3, 9. 6 plus 3, 9. And 6 plus 1, 7. So that's 7,992. Once again, if we had, for example, 33.3 times 2.4, we would look at how many numbers in our factors were after the decimal point. There's 2, so we'd have the same answer in the same order, but now we would need 2 numbers after the decimal point. So our decimal point in our final answer would be 79.92. So this is a very useful technique. Do the multiplication without decimal points, and then at the end actually look at the factors and add the same number of digits after the decimal point in the answer, the product, as there was in each of the factors. So good luck with choosing a different method of multiplication that you enjoy and find easy. Thanks.